Good morning, children. In this video, we will be discussing preparation of phenol from diazonium salts. See, if we write the equation for it, it is, this is aniline, C6H5NH2, aniline. Aniline, you will have to treat with NaNO2 HCl. Temperature has to be very low. It is 0 to 5 degrees Celsius. Or instead of this NaNO2 HCl, you can also write HNO2. Because HNO2 is very unstable, it cannot be directly stored in the lab. So it's always prepared in situ. We use this term. HNO2 is prepared in situ. In situ means within that reaction it is prepared. So you will be mixing these two, and these two will react and will form HNO2, which will carry out the reaction. So if we just write the reaction, in the first go it is forming diazonium salt. This is benzene diazonium chloride. Benzene diazonium chloride. And what is this? Aniline. Aniline, or if you are writing the other name, it can be benzene amine. Right. Now this benzene diazonium chloride, when it is treated with warm water, it results in the formation of phenol. So if you are learning that reaction, this is the reaction. You have prepared phenol. But in this video, we will be also discussing the mechanism of that whole reaction. Right. So let's start with the mechanism. So now mechanisms are actually always proposed later on. The reaction occurs and it's just a proposed thing, like this would have happened in the reaction so as to form the product. Right. So what exactly happens in this is, in the first go, this NaNO2 and HCl, these two will react and will result in the formation of NaCl and HNO2. This is just exchange happening, H with NO2 and Na with Cl. So these are the products which are formed. This is nitrous acid. HNO2 is nitrous acid. Then what would have happened to this nitrous acid? So if you open up the structure of HNO2, it is, there are two lone pairs of electron here. There is a single bond, N, double bond O. This reaction is in the acid medium that we have already done. HNO2 is formed and HCl is also used, which is an acid. So oxygen having the lone pair can pick up this H plus from here. It can pick this H plus from here and it will get protonated. So what will be the first product what you are getting? O, N, double bond O. This we haven't done anything to it. One lone pair will be left over and one lone pair is utilized to form a bond with H, and this O will now have a positive charge. O with a positive charge is never stable. So what it does is, this oxygen pulls the electron pair from here and it will now have both the pairs back on it, and it will result in the formation of water. So this bond will break, it will form water, and now this nitrogen is short of electrons, so it will acquire a positive charge. So N double bond O, and there is a positive charge on this. So this product which is formed here, this is an intermediate, it is called nitrosonium ion. It's nitrosonium ion. So this nitrosonium ion will now carry out the reaction with aniline. Okay, please make note of this so that I can move on to the next page. So now what happens is, aniline, in which nitrogen has a lone pair of electron. Nitrosonium, which was formed here, it attacks that nitrogen atom containing the lone pair of electron. So this lone pair of electron on aniline can be given to nitrogen containing a positive charge of nitrosonium ion, and this is going to get attached here. So how we can mention in the next step, this remains as such. So I'm just opening these hydrogen atoms over here. This NH2 I've opened it, and onto this nitrogen one lone pair is given to this NO. So that positive charge will now disappear on this nitrogen atom, and it will appear on this because this nitrogen is now having 4 bonds. Here it was fine 3 bonds, but 1 pair is given to it, so it is now having a positive charge, right? So now this species which is formed here will be little unstable because positive charge is there on nitrogen atom. So what it does, it tries to take this electron, nitrogen hydrogen bond is there, so this electron pair is taken by nitrogen, and it liberates this H plus. So this H plus comes out, this nitrogen gets a pair of the electron back. Okay, so what you will write here is this bond here, this will be N, a single bond, N, double bond, this one, and one H is left over, and it's getting its pair back. So that lone pair is it has come over here on nitrogen, and the positive charge will not be there on the nitrogen atom. Right, now in this particular molecule which is formed here, that there can be a tautomerism. There can be tautomerism. Now why there is a tautomerism, you can just observe the structure. Whenever a double bond and this H on O or on nitrogen atom, so this is in alternation, okay, then there can be tautomerism. So what it is in this bond will shift here, and this hydrogen will come this side. So this bond from here shifts this side, and hydrogen will come this side, and it will rearrange itself to form another species. This you can just write like this. There will be a nitrogen atom. Now when this has come here, there will be a double bond, nitrogen, O and H, because that bond has gone here. Now this will be another species which is generated. Right? Now in this particular species which is generated, there are on the oxygen atom there are 2 lone pairs. So one H plus had come out here. This H plus again attacks the species. So this H plus will be picked up by the lone pair of the electrons present over here, and you can just see clearly water is about to be eliminated from here. So in the next species, what you're going to write is, you will write here N, double bond, N, O, H, one lone pair has gone, it's given to H. There is only one lone pair left over. Now there will be a positive charge on oxygen atom. Right, now things are becoming little more clear. So this is containing a positive, oxygen is having a positive charge. So what it does, it takes the electron pair from here and it comes out as water. So in the next structure, what you will have is this species is retained as such, nitrogen double bond, this nitrogen. Now water is eliminated, so you will write down minus water over here, and now this oxygen, this nitrogen atom will get a positive charge short of bonds. So this is another species which is generated. Now within this species, what will happen is this nitrogen getting positive is not stable. There is a lone pair of electron present over here on nitrogen atom. It's pulled up by this particular nitrogen having positive, so it will be now a triple bond in the center. So you will have in the next structure this N triple bond, and now this nitrogen will get a positive charge. Right, now this is now the diazonium ion which is generated. Now it will now be attacked by Cl minus, because we just started the story with this. H started the reaction and Cl minus is still left over. So that Cl minus with this will now result in the formation of a diazonium salt, which is N triple bond. You will have this and Cl minus along with it. So it has formed benzene diazonium chloride. Right? So please note down till here. Then I will continue on the next page. Yeah. So now in the next step, what happens is this benzene diazonium is a ionic salt. You can see there is a positive charge and a negative charge. So there is ionic bond between the two. So ionic bond, when we were carrying out the reaction with warm water, we said in warm water only it is forming phenol, we said. So in warm water, when you are dissolving this, it is getting ionized. Any ionic compound, when in water, it is getting dissociated. So what will occur here is this compound undergoes dissociation. So when it has undergone dissociation, it will result in the formation of chloride ion and this ion. So what is the ion being generated over here? It will form this N, a triple bond, N with a positive charge here. This ion will be formed, plus of course there will be Cl minus also. Right. So this ion which is generated here is having a positive charge on nitrogen atom. So what it does, it pulls the electron pair from here, and this positive charge disappears. So this compound comes out here over here as nitrogen. So nitrogen gas will be eliminated. So once the nitrogen gas is eliminated, what you are getting here is this ring with a positive charge on the ring. This is a phenyl cation. So phenyl cation is not stable. So as soon as it is generated, we are having this solution of water. This we have put in warm water. So water is having H plus and OH minus. So this being positive pulls the OH minus part of water. It pulls OH minus part of water and it forms a bond with it, and thereby resulting in the formation of phenol. Plus this Cl minus and H plus of water will also result in the formation of HCl. So nitrogen gas was eliminated here itself, and then OH minus of water has resulted in the formation of phenol, and there you are. This was the product which we were looking for. Okay, so with this we complete the mechanism of preparation of phenol from diazonium salts. Hope you have followed. Thank you.